Just wanted to make a quick reminder that we have an open problem session tomorrow at 3:15.
Not that I think I need a microphone. Is this working?
Yes.
Okay, great. So thank you for joining us for the only panel for this workshop, unlike previous workshops. So the panel is on statistical theory, privacy, and data analysis. On the TVs for us in the room, you can see actually who our panelists are, and I will just take a minute to introduce everyone. And perhaps instead of going in the order they appear on the screen, which was alphabetical, I'll start from our guest of honor, Bin Yu, who is distinguished faculty in Department of Statistics, Electrical Engineering, Computer Science here at Berkeley, and she does not work on privacy, has not worked on privacy, but I thought it was very important to have somebody, let's say, from the outside our community to give us perspective on science of data analysis and how does this fit with work on privacy. John Duchi, faculty at Stanford University, you just heard him speak, and I guess as he described himself, he works on many, many different things and has electric interests, so I'll just leave it at that. Yu-Xiang Wang is the assistant professor at UC Santa Barbara. He works on machine learning and data privacy as well. Thomas Steinke is a researcher at IBM. Many of you, of course, know him. Mostly works on, I guess, theoretical computer science, but both privacy problems and algorithmic fairness. And Anand Sarwate is an assistant professor at Rutgers University in statistics, first electrical engineering, but also with affiliated appointment in statistics and computer science. He works also on machine learning optimization and statistical problems. And before we continue, I also want to give us a really hand of applause to Anand, who really, despite having workshop co-organizers, really organized this workshop. So please join me at least. We have offered to anyone who is who is watching remotely to send any questions via email. And here, if you don't want to raise your hand, you can also send an email. I'll try to monitor my email. So, what are the main questions for the panel? We were interested in hearing, or for panelists to start telling us a little bit first about, from their point of view, what do they mean by science of data analysis? Because I think we have different communities here, and it would be great to hear what we mean by that. So, and then the second important question that we're interested in addressing is how can we bridge the gap between theoretical concepts in both computer science and statistics, and make these theoretical ideas turn into real applications and reality. So how do we go from theory to methodology? We also provided panelists with 2 concrete examples just to help them perhaps think about a little bit more about the science of data analysis, but we would love to hear from them and for everyone else more broadly than just on the concept of statistical significance and adaptive data analysis. The reason why we chose these 2 as examples, because there's actually an ongoing debate in the statistics community right now on how to report statistical significance, and this is a very, very important topic right now. And of course, there's a lot of work in both communities and in social sciences and other areas of science on adaptive data analysis. So these are 2 examples, and I said we'll welcome other ideas and other examples. So I will start with John Duchi.
No.
I wanted to. I didn't want to put Bin Yu on spot, but maybe Bin Yu. Okay, so let's start with Bin Yu.
Experts first, right?
Expert first?
Yeah,
okay.
Yeah,
Anand also didn't want to start first, but I'm going to put him on the spot.
Wait, what's the question?
Science of data analysis. What do we mean by that? Your general perspective.
Oh, I guess I do work with scientists, so that's I guess so that's important to think about. I mean, we talk about science, we're talking about the creation of knowledge, or we at least pretend like we're talking about the creation of knowledge, some problems in epistemology. And I think a lot of times, as an electrical engineer, I'm not afraid to call myself an engineer, we work on the engineering of data analysis. So we work on saying, oh, here's an algorithm, let me make this algorithm a bit better, but that's not the methodology on which these algorithms are used. And especially in complex, working with complex scientific data, which may be about individuals, which is where the privacy comes in. The methodology is quite complicated, and we don't necessarily always acknowledge that when we make claims about the algorithms that we design, because they're going to be used in some context. There's going to be pipelines of them. There's complicated issues around parameters. So it's not a matter of just sort of swapping out this test or that regression for a new one. And I think we have to think when we think about science like a bigger picture than individual methods.
I have my own mic.
You don't need mine.
So it's a very broad question. So what I would think of as the science of data analysis is the process of taking data which was collected somehow and turning it into true and meaningful conclusions, where by true I mean generalization or having some method for quantifying and understanding uncertainty, which is always present. And by meaningful I mean either it's interesting or useful or solve some problem somewhere. And the science is just coming up with various methods of doing this important task.
Yeah, I very much agree with Thomas. I just wanted to add like one more point. So I think the science of data analysis should also include the data collection phase. So you decide what kind of data you collect and how to collect the most meaningful data to answer the kind of questions that you're asking. Besides that, I agree with everything so far.
And can you also comment, maybe you can go back around, like how do you feel your definition fits within the privacy or context or with privacy? But we can come back maybe to that if you want.
I think I guess social responsibility, other kind of constraints, privacy and fairness are the new desiderata that we definitely need to take care of so that we can do things more responsibly. Because ethics is an important aspect of modern science of data analysis, in my opinion. I'm happy to be here.
Do you want to go?
I have a weird riff on AI, but maybe that should be later. I don't know.
You want me to go?
You can, yeah.
Okay.
So for me, it's really the whole iterative process of starting from problem formulation and together with domain scientists and discuss design, data collection. It's really something I'll call empirical rigor that we all have to define collectively. You do data collection, and that's probably already have privacy issues there. And then you go to data cleaning, which is something we do and we put it under the rug. That you can lose privacy, you can add privacy, it depends on how you do it. And then there's data visualization. And then to the modeling stage people care about. And then you do post hoc analysis, do visualization, interpretation. And then you might collect new data and you reiterate the problem formulation. So for me, it's this iterative process of statistical investigation, which George Box, a statistician, definitely wrote about in the 60s. Right now, we call data science lifecycle. And in this particular cycle, my group and myself in particular have been advocating stability considerations from problem formulation. And I think differential privacy is actually a form of stability in some sense. You basically try to make things control things far apart. And it's really about solving problems. I think we have to focus the science of data analysis for problem solving instead of just data. Data is relative to a problem. Without a problem, I don't think data is that meaningful.
Okay. So this is sort of a bit of a tangent, but I've been, sort of watching machine learning and statistics morph into data science, which then morphed into AI and brains over the past like 10 years. And I've been sort of thinking just broadly about education and how that interplays with this kind of like AI is everything. So there's a recent article by Mike Jordan called AI, the Revolution Hasn't Happened Yet. I don't know if you guys have read this. But it's a really interesting article, and sort of the point of it is that clarity of thought and discipline is extremely important. So, you think, okay, there's TensorFlow now, right? So Google has released TensorFlow, and anyone can download this and type Go in Python or whatever the command is. Probably not Go. But I use C++, Vitaly. But it's not. You ask, like, how did we get to the point where we can actually do this analysis and build these systems and things like this? And there's huge amounts of investment in kind of, numerical optimization. You open any machine learning textbook, it starts with basic concepts in statistics and probability, right? And so for me, I mean, for those of us in the academy or in industry, thinking about where do we actually invest in terms of providing, funding, investment, things like this for education and things like this, I think it's really important that we not call just everything AI and AI is going to solve everything. It's like, what are the actual meaningful disciplines that underpin these subjects? I mean, I know that's not the topic exactly of the session, but I don't know, I'm pre-associating, I guess. But
How does it relate to science of data analysis?
how does that relate to science of data analysis? Well, I mean, if you open up the New York Times, there are editorials every week by very famous people, like the head of Scripps, right? This guy is an MD, and he wrote an editorial in the NYT. The Scripps, no, not Scripps. What's the medical institute? Is Scripps the medical institute? What's the medical institute down? Sorry, Scripps is. What's the medical institute in? Salk, maybe? Salk, yeah. So the head of the Salk Institute. Sorry, thank you. And so he's an MD, and he writes this editorial that says, "Let AI choose your diet." But he bases his entire article on a paper that was in Cell Biology in 2014 by Aran Segal, who measured like glycemic responses and gut microbiomes and flora in like 1 million people or something insane like this, right? But it wasn't AI who decided to run this experiment. It wasn't AI who decided what to measure. I mean, there were just fundamental biological statistical questions, and the method they used to fit the models they were using was gradient boosting, which was in the Annals of Statistics in 2001. Right, because that was what worked the best. None of this is AI, but like calling it AI sort of obscures like all of the deep scientific rigor that went into this. And to me, this is a little distressing that the head of like a major research institute is writing about this in the NYT. And I mean, this is a guy who will influence science policy in this country, or at least at major universities. And I think all of us, it behooves us to be very clear, like. I mean, one thing that I love about like the privacy literature in general is like there's a very clear demand for rigor. If you say something's private, it better damn well be private, right? Like there has to be a proof associated with that, which is great. But I think, just broadly as we think about like data science, AI, all this stuff moving together, it's important that we nail down what we're doing and why it matters and how we did it.
I kind of agree with what you said, but the question is, do we control the use of vocabulary in the outside world? Right, that's the problem. Is the whole society, industry hyping it? Right, I mean, in some sense, right. Do we have the power, or we just should redefine with a new name we can define, and people can still take it and give meanings? Yeah, so.
I'm glad I'm a data scientist now and not a statistician, because statisticians are boring. I'm in the stats department.
I feel like what you're saying is that AI is not the science of data analysis.
Yeah, that's part of it. But I also think, I mean, I actually really like the idea of like saying there's a science of data analysis and being rigorous about what it is. But I don't know. I don't know the answer to your question. Like, words aren't just aseptic labels that mean nothing, though, right? I mean, they have meaning.
But academics don't own actually defining meaning. That's the problem, right? I mean, if you leave it to statisticians, we probably, a lot of statistical idea being called machine learning, right?
Yeah.
That's all done by academic people too.
Anand?
But I guess
Actually, I want to pick up on what things that both of you said. One was about working with domain scientists, and the other was sort of about how, I guess your point about language. One thing is that maybe from the outside, and I guess I'm on the outside of it, you think of statistics as being like, oh, there's a formalism for statistics, but then if you look at actual statistical practice, it's like a collection of some loosely associated methodologies that are, kind of patched together. It's like a morass of like what people do in very different in different fields, extremely different, and not just like what kind of tests they do, but like how they handle the data and all this other thing. And I guess one question I have, and I'm not sure, is like, is there a one type of rigorous methodology that we should then try as educators? I guess the other point I want to pick up on what's the role of education, that we then say, okay, now this is the right way to do things. There's one right way to do things, and then we should try to shoehorn existing statistical practice, corral it back, not like in a fascist way, but in a sort of progressively as we go along kind of way, to get people on board to sort of be doing it with more empirical rigor.
Sticking with me. So actually, I've been trying to do things like along the lines through teaching, because what I agree with you that after I've get my PhD practice for 30 years, it's not easy for somebody else from outside to really get on top of it. So that's why we have been developing 3 principles, like basic building on machine learning and stability. And for this semester, I'm teaching a machine learning class, and I came out with this 3-circle idea. It kind of hinges on your second question about how do we relate algorithm with reality. And I realized that traditional statistics, we kind of put it together: future reality, today's reality, repair the data, and algorithms. So I kind of start from 3 circles and say the algorithm is a mental construct, exists in your brain in mathematical symbols. So you have to bridge the gap from reality to algorithms through documentation, both English narratives and quantitative narratives and visualization to bridge the gap. And if you subscribe to our PCS framework, you will have to document with reproducible codes and narrative to back up assumptions, explain why you do things certain ways. So I think that's a step forward to bridge the gap. But if we teach everything as if they're always together, we have a probability model, and we do maximum likelihood, and we have future data from the model, you don't have to deal with these questions. But I agree that education with John that it's going to be a step to teach this rigor and define this rigor.
So I think if I can interject, so basically what you just described a set of steps, and if I understood you correctly, you're advocating for the transparency of those steps.
Exactly.
In statistical analysis. But
also have high-level principles which you apply, like physics, hopefully, that when the methods change, but these high-level philosophical principles don't change, like check for reality. When we teach classes, people just run models without ever worry about checking for reality. That should be the first bit. You need to have some way of checking reality, prediction or not.
Okay, so let me see if I can also bring this back to the question of privacy, right? Because we want to see how these concepts relate to privacy. So one, at least differential privacy is advocating for transparency. So it seems that at least the formal, let's not say differential privacy, let's say formal privacy methodology advocates for transparency, and that should go along with what you're advocating in terms of transparency of statistical process, right? Now this question of check for reality, I would like to learn a little bit more about this because I think this is very important, and we're starting to implement formal privacy methods on a large scale, including census, some of the industries, right? So what do you mean by checking for reality? And again, anyone else can pitch in. I just thought maybe this is one way.
Yeah, for me it would be like, I think DP, we have done a lot of theorems. I'm not on top of everything, but seems to me I like to see a lot of empirical studies and bring social scientists in and to apply data already exists in the past, add differential privacy to it, and see whether the analysis could be done, right? Because there's this transparency versus accuracy for analysis downstream, right? For the analysis batch, you don't hide, you don't mask anything. But for privacy, you do. So there's a trade-off between transparency versus accuracy of downstream analysis.
So one of the most important feature about differential privacy is transparency, and it's about how universal it is applicable. So suppose you say an algorithm is epsilon differentially private, then no matter which data sets you substitute into this algorithm, it's always going to be epsilon differentially private. But one thing I think that is extremely important when you try to apply that in practice, which leads back to Ping's point on transparency and trying to ground your algorithm to the reality, is to understand in every scenario what that epsilon actually mean for this particular setting. It really depends on, like, epsilon is an upper bound on the privacy loss, and it really depends on how crude that upper bound is for every instance separately. I don't think we have enough well-defined procedures to answer this kind of questions in each application.
So, yeah, bringing privacy into it, I mean, there's one sort of view that privacy is opposed to utility from having access to data, but I don't think we should restrict ourselves to that view, because first off, privacy-preserving technologies are also a way to open up new sources of data, which will help improve the conclusions that we can reach. And also there's the recent line of work in adaptive data analysis, which shows that there are actually some side benefits of accessing data in a differentially private manner. First off, it enforces good data hygiene. You're not going to be going p-hacking or phishing for stuff if you're accessing your data through a differentially private interface, but also more formally, there are generalization guarantees that are given to you by differential privacy. So, and I think we should view privacy as also potentially being hand in hand with the usefulness of data to science.
I mean, I guess the thing I'm working on, it is in fact being able to tell somebody who has a data set that we will access your data set only in a differentially private way is an incentive, and actually you can see that people are willing to participate in a research collaboration because we're doing that. So that's certainly true. But the challenge of setting a reasonable value of epsilon is very opaque to me as well. And I can do it through like some sort of cross-validation, but then I'm eating up my budget like trying to set epsilon via cross-validation. So I'm like, it becomes a. I think I like to think of the scientific methods. I have a hypothesis, then I code and collect data, and then I check my hypothesis. But that is never the way it works, and I just end up having the data that I have. Right, so
it works that way in 4th grade, I think.
Yeah, it works that way in 4th grade, right? So so I think having a holdout, a reusable holdout, and that kind of thing is really great. But in some scenarios, maybe that's not easy to come by with or without privacy.
So I think somehow, so I'm very receptive to these ideas of, okay, if we have privacy, then that enforces a kind of stability. We know that stability is super important in different data analyses. Let's ask a slightly different question, like, okay, what about, industrial applications, Google, Apple, Facebook, etc., right? So there, at least right now, there seems to be some kind of tension between kind of privacy protections and services provided, right? Like, it's very useful for me if my phone can, predict the next word I'm going to type, because, and what I type is presumably different from what you guys type, and so like a local model to me that's really good is maybe kind of useful, right? And so, I mean, I don't know, but I guess one question is there some way we can kind of combine some sort of like best practices, like not letting perfect be the enemy of the good, right? Like if somebody says okay, well, we're going to try to do this privately, and then we say, okay, well, that's not private enough, it's no good, then you're like, well, actually, we're going to just sell all the data to Cambridge Analytica, so whatever, right? Like, that's not where we want to end up, I guess. And so I don't know how this tension should play out. Like, there are some. Like, I guess, Cynthia, are you involved in SS1?
Yeah.
Social Science 1? And so I think some of these tensions are rising here. Like, my understanding is that different researchers are going to be given some epsilon budget or something like this, and then expected not to collaborate together to break things or something like that? Is that not the case? Do we know what's happening yet there? This is an honest question. I don't actually know.
There may be a definition of we, but I cannot say that I know what's going on there.
Okay.
How about like a medical health record, right? I've been trying to get data from UK Biobank,
Sorry.
and it's so hard. So.
What is hard about it? Do you mind
Just-
giving an example?
So UC doesn't like whatever the document we have to sign with Biobank, and they will sign the separate thing, but just so much work to even get. And now I finally got permission. Now I have to add my team. It's another few weeks. So I don't know. I don't understand the privacy aspect of that medical record. Do people here understand what's going on with the medical records? What's going on there? How the community is working with people or not? They just make arbitrary rules. They definitely have privacy concern. That's why they asked me to sign tons of documents. But I don't understand why, but I'm just doing it just because I have to do it.
As far as I know, the medical record privacy, at least in the US, is a total disaster because basically the law says you remove PII and you're good. And as a result, hospitals will basically sell patient data, and they just take out a couple of identifiers and hand it off to anyone who's interested.
Oh, really?
Yeah, I'm not an expert on it either, but I thought the HIPAA safe haven laws said that there's like a list of 16 identifiers that you're expected to remove, and once those are removed, that it's supposed to be
Do
treated
we know what's going on in the medical community?
I mean,
privatized in some sense.
yeah,
Oh, really?
but they don't do a great job of it.
Well, I mean, actually, so I don't know. I mean, I know of some data. I know of some data sets which have been released under safe harbor, but I don't know any. I don't think there's like a collection of like all of these data sets have been released under safe harbor.
Okay, that I certainly don't know.
So the degree to which, although it is possible under the law to do something like this, I don't know to what degree it's, posted publicly, like, or sold in the way that you suggest. I mean, I'm pessimistic too. Like I'm a cynic, but the picture you're painting is a bit more nefarious than I don't know if is warranted.
I mean, I guess if they're allowed, I mean, if they can make money selling it, then they have a great incentive not to put it out publicly.
I mean, there are also medical data sets that are available for free. And it's kind of scary. But, they're out there. They just remove names,
I mean,
shift dates.
I think one thing we're missing is also the informed consent process to talk about the data collection process, right? So sometimes people have consented to have that information shared.
But without them knowing it about it.
Yeah, of course you don't inform. There are no post consent informing. There's only informed consent at the beginning, often. But I think we're kind of far away from science of data analysis.
Well, I don't think we are, because many of researchers actually work with health and medical data, and especially you talk about precision medicine these days. There's a lot of effort put into that, so I think we're not far from it. But before we continue, I want to make sure that anyone in the audience, at least here, if you have any questions or something you would like to ask our panelists. Otherwise, I will continue with more questions I have. Oh, please go. Oh, yeah.
So in like science, so in data science, there's a lot of like, if you do like hypothesis testing and stuff, there's like asymptotic results that you sort of rely on. But then when you want to include privacy, this thing needs to hold all the time, right? So how do you sort of make amends of this? Like, privacy all the time, utility asymptotically. How do you bring that together?
I mean, ultimately, you want the most precise result for the finite sample for both accuracy and privacy. That's not always easy. That's the reason why people go by asymptotics, because then, like, for a much larger class of problems, that you can actually calibrate, say, the type 1 error to precisely what you want. Like, even doing that with differential privacy is a challenge, and I think the community is still working very hard to get there.
But I guess like some in like papers, like you'll have like a level of significance, right? And then like that'll be the determinant to whether like a drug goes out there, right? But these are sort of based on asymptotic results.
You mean the
It's like
Sometimes.
translating a p-value into.
I mean, there are non-parametric ways you can do things. You can do permutation tests, which works for finite sample. All you need is exchangeability. For confidence interval, you can do things like bootstrapping. But yeah, that's more of asymptotic stuff.
What's your thoughts, statisticians?
I mean, so asymptotics are very elegant and nice because they give us the right constants, right? I mean, it's like, here's the constant, it's 1, the end, right? I mean, part of your answer is, you can go read Adam's paper on asymptotics and statistical estimation with privacy. Then you get to smush them together. But I think another answer is that there's a movement in, this isn't really dealing with the privacy question, but there's a movement in statistics to trying to develop new flavors of asymptotics. Okay, so which is to say, I have a dimension d, or like I'm going to do d hypotheses tests, and I have a sample of size n. D over n goes to a constant as n goes to infinity. So they're scaling together. And this is a very different asymptotic regime than what we had in the past, and it seems actually often to make better predictions, at least for a lot of problems, than what classical asymptotics give us. But the tools to develop these things are extremely sophisticated right now. And there is some hope that maybe this helps address some of these issues of false discoveries and things like this, because you say, okay, we have our classical Bonferroni corrections, we have our like FDR control, false discovery rate control, and things like this, but potentially a new version of asymptotics where we actually understand like the scaling of the ratios of things and then the exact constants in those scenarios may help us beyond this. But the examples here are right now quite sophisticated, and the analyses are fairly bespoke, really tailored to the problems at hand, and we'll see where it goes. I think it's a very promising area, but right now we don't totally understand it. I don't know.
So I think the elephant in the room, actually, a lot of times, unless you have explicit randomization, actually in DP you do, that why we use probability statements is actually, I think it's the first order problem. Then worry about how to interpret p-value, whether p-value is calculated right. That often any data, people just start putting basic ID probability models. And that has consequences downstream, huge ways. That I think this is the biggest problem why you don't have explicit randomization. That you just have data, you just start throwing models and probabilistic too on it. And we start interpreting asymptotics, which is a probability model, and we interpret p-value. Of course, asymptotic result is really weak convergence, right? It's really not really strong approximation. Why we should read off the normal curve 10 to the minus 8, that's beyond me. Right? You cannot trust normal curve that small tail, right? You should go with large deviation, but we don't. So all this, but that's a second order problem. It's actually when we start postulating probability model when there's no explicit randomization that worries me most these days. That you sometimes, if you only have one data set, you really don't need random variable. If you need random variable, you're really thinking there's another situation where things could have been observed as a realization of the same random variable. And implicit is assuming stability, right? There's another physical situation that can put two data as two realizations. If you cannot even think about another realization, why do you need random variable? You should just stuck with your fixed data. I mean, I've been teaching for 25 years without blink with X1 through Xn starting my lecture, right? But the last 5 years I'm pausing. And I don't introduce random variable until like third into the semester and be very, very careful.
But how do you do inference if you don't have some kind of probabilistic
Well,
model?
I would just make it transparent. That's in our PCS framework for my group. We call perturbation intervals. So you do just perturbations through subsampling, and that's what you get, right? If you make sense of it, maybe it's too useful, then I'm not using the probabilistic framework. Mine is not justified. Just saying that's exactly what I do. I perturb the data, this is how I did it, and here's the perturbation intervals. It's kind of inference, but I think it's more honest than throwing a probability model without any backing.
I mean, this seems more like non-parametric statistics, where you sort of
No.
try to make the minimal assumption.
No,
right? You just say-
non-parametrics do need probability models. I'm not trying to say if you cannot just say probability models, I'll just say that's how, it's kind of algorithmic. I'll call that algorithm modeling. It's just preserve the data this way with a code, and that's what the differences you get.
It's also a bit like how you would evaluate robustness of an engineered system.
Yeah,
You apply
stability.
You whack it a couple of times, and in
exactly.
a systematic way, you whack it, and
If it's useful, it's useful.
then you make it part right, and then you say it's so. But I think that's why I'm trying to draw a distinction between somehow science and engineering. Like that's an engineering approach, and the question is, does it create? One question I have is, do we create knowledge, or do we learn something true about the world when we do that? And I think we do learn something true about the box that I've engineered and how it behaves.
Yeah, we always just say, here's a property distribution. We learn something about the parameter.
Right.
But why is a property distribution we often don't discuss?
Right.
I mean, I definitely did it. I'm just as guilty as everybody else, right? That's how I was taught, right? That's a given.
But I think I want to dive back to, I think this question actually came up yesterday, why Poisson distribution was the right distribution for... Katrina asked the question, I don't know if she's around or not. There was some creation of synthetic data. And this is a question that we do often ask in statistics as well when we model, right? So, but we do, for, I guess, to simplify our life often, make assumptions and believe that certain model is the right model. But this is a very important question, and it's an important question for privacy as well. I think another thing that may be relevant for this audience, tying to what Binu just said in terms of not actually calculating p-values based on probabilistic model, but actually using perturbations. We're starting to teach in our intra-statistics courses, what is really a p-value, but from a perturbation perspective, and simulations and randomizations rather than thinking specifically about probabilistic models. And I think when you speak about randomization perturbations, I think those ideas are also, there's close link with privacy concepts. And so that's another avenue. But I think Phil had a question.
So I think a common concern that I've seen expressed within sort of the external community of experts that are not privacy people, but are interested in using the end data, is sort of a reasonable concern, which is given that you passed the data before publication through a rigorous privacy mechanism satisfying DP or some other formal privacy definition, how can they, be able to sort of play with the data in an exploratory sense to sort of find patterns that they think are interesting, but weren't about queries that were anticipated ahead of time? And I had a B, but I've sort of forgotten what it was. I suppose, though, the key part of this question is sort of the obvious way to deal with this is to try to target a really large class of queries by generating microdata. But I think my impression, at least, is that that is very difficult to do, and I think there are also some theoretical results suggesting that it in general is quite hard. And so I'm curious if you all have any thoughts about how differentially private sort of exploratory data analysis can be sort of improved, made easier, and scaled up to handle large groups of users externally.
First, my pushback that people have been cleaning data in whatever way we don't know, and then they have no problem doing data exploration. So I find it strange that when you have a very systematic way adding noise, and they have a problem doing EDA, right? So it's just like, if you have a problem, we clean data, we don't talk about it, and then we have no problem doing EDA after data cleaning. So I don't see why people have problem with that. That actually you know exactly what you did to the data, then you do visualization. So I think they just ignore the data cleaning problem.
I think this is an extremely important problem that raised. So this goes back to, I think, to the very heart of the science of data analysis, in that how do we enable scientists to actually look at the data, play with the data, and do the kind of interactive data analysis, exploratory data analysis in the way that they are used to. In the new era, when we are expecting things to be more rigorous and to have provable guarantees in terms of the privacy of the individuals. I think this is really the very heart of the problem that people should think about.
So one other spin to put on this question is, should people really be playing with the data before they do the analysis? I mean, there's a lot of debate about data analysis, about p-hacking, and the potential that people are basically doing things that they shouldn't be doing, and then once they start from that point and do a data analysis, the end result is no longer valid. So One way to sort of respond to the question with another question, which is, what sort of exploratory data analysis should one be doing?
I mean,
Go ahead.
Yeah, okay. Well, I mean, I think some folks, I mean, there's some folks have started to try to build like database systems that allow you to do this, right? I guess this is like Pink, and I'm sure there are others that I just don't remember. Like privacy integrated query languages, Pink. But you could imagine basically like an R shell, and you implement, say, all the commands in R, some subset of the commands in R, base commands in R. And each time you call one of them, it actually just runs a differentially private thing under the hood and spits out the result, right? You could certainly imagine.
It's the dream.
Yeah, you could imagine.
We're pretty far from there.
Yeah. I mean, I agree, but but potentially, maybe you say, look, we can do this, and we're not actually going to provide that great of privacy guarantees because we'll just let you keep noodling around with this data until you're done, and so your epsilon is 475 or whatever. But maybe it's better than nothing, or maybe we're just like, no, that's a terrible idea. I don't know, but potentially something, starting to build like basically like R or Julia or one of these kind of interpreted statistical data science languages with some privacy stuff under the hood might be a cool way to do this. But I don't know.
Yeah, well, I didn't want to stop. I wanted to ask a different question.
Oh, okay.
And apparently you don't need a mic. The people in the audience don't need a mic, I was told.
Okay.
Do you want to? So maybe I'll just make one comment. The one article or series of articles that we sent from the American statistician, we shared the link with everybody on reporting statistical significance. There was an interesting proposal there where they said, okay, so we don't want dichotomized decisions or discretized decisions on statistical significance any longer. But perhaps what we should be doing is everyone should be doing exploratory data analysis, reporting their exploratory data analysis, until from only exploratory data analysis, we converge to something that looks like a strong hypothesis that actually could be tested. There's just to add in terms of exploratory data analysis is important, and you can look at it from many different perspectives, and I think this is something that we, as a privacy community, really have to think about very carefully about how we can incorporate or develop tools to allow practitioners to continue to be able to do exploratory data analysis, even if it's with differentially private data. And there are many reasons for that. But Adam?
I guess I was going to raise a somewhat related point, but it's different, which is about sort of reproducibility and privacy. And the question was, if we want to move to a world where researchers are very careful about what they publish in their papers, how do we, I guess Phil was mentioning this earlier, how do we find bugs? How do we inspect the process? We can inspect their code, like that's not so hard, but going back to making sure there weren't stupid mistakes made at various points is like much harder if you can't expose the entire sort of pipeline in the clear. And so the question is sort of what infrastructure is needed? Do you need a place where people deposit their data, and then there's like so that there's some verification that what is in their paper actually came from running the code they claim they ran on that data? Do you have cryptographic proofs? Is there, are there any good solutions to this? And how do we also stop it from researchers from using it to prevent reproduction, right? To make it, harder to reproduce their result. Do you have any thoughts on that?
There's some work in the statistics community. So Dylan Foster at Penn has tried to get folks to sort of not Dean Foster.
Dean Foster.
No, not Dean Foster either. Dylan Small.
Dylan Small. UPenn stat?
Yes.
Dylan Small.
Sorry, too many.
Mixed up two people.
Too many Dylans and whatever. Anyway, but he's tried to get folks to sort of pre-register, like basically treat observational studies where you're kind of looking for causal things as almost like he's trying to set up things where you can pre-register the studies you're going to do at some kind of clearinghouse and things like this. So there's movements here. None of them are going to have like zero knowledge proofs or anything like this that you're certifying, okay, this is what I'm doing, but you sort of, there's some level of trust that somebody pre-registers, then they're going to do the analysis that they said they're going to do. So there's bits and pieces of this coming up, but there's nothing, I don't think there's some global monolithic entity which is certifying this.
I mean, I think part of the problem is that a lot of researchers, their incentives are to keep their data sets to themselves because the data set is a gold mine and they're going to publish as many papers as they can before they let anyone else touch it. So, you know, how do we set up the incentives? I mean, it would be great to have, you know, a central repository where all the data gets placed and other people can come along and replicate studies or perform other studies, but I think the incentives are the real question.
But I think like journals like PNS is requiring data depositories.
Yeah, but then people just come with the excuse that it's private, so we don't need to share it.
No, they're becoming very, very serious these days. Like 2-3 years ago, similar people got away with it, and we submit paper. We have collaborators who really forced to share the data. So I think they're getting very serious. So that's one way to do it, and I think NIH is also requiring a lot of data sharing.
I think Adam's question was like about, was more about like, you know, how do you validate the methods that are being used? Less, right? I mean, how do you ensure that what people will say that they're doing is what they're doing? And I guess one way that Sci tries to do this is by limiting what people can do, right? In some sense, right? It says could pre-asks all the questions when you registered a data set with Sci. Since I'm here only here because Salil couldn't make it, so pretend like I'm represent. Sci is really great. You should use. But is, I mean, does that solve some of it? Essentially, then you know you're trusting the person who implements that system. That the analyses that the subset of analyses that they did were done in the right way. And so I guess, do you build on that? Well, I guess one question might be, do you build on that starting point, expand that out, or you're thinking about something a bit more open-ended?
I think that kind of, that addresses some aspects, but I somehow feel there's probably like a bigger issue there. Well, first of all, you can't force everybody to use like the same system. Well, you can try it, but it probably wouldn't work. But yeah, just in general, how do you it's not even about like malicious use of the system, of people maliciously trying to prevent reproducibility, but just like if things are differentially private, how do you know, they could have bugs in their random number generators and all sorts of stuff that isn't apparent from the code. And, it just becomes much harder to verify what's going on. Sort of, the code can only be run once on the real data.
I think one way is really like when people in undergraduate education for our data 8, right? Students start using IPython book, which is more habit forming. That will help. And for different groups, take a protocol to make sure things are reproducible. So I think that's eventually probably help everybody instead of like punishment. It's really train students in a more reproducible way.
So in terms of sharing data, there are issues associated with forcing researchers to share their data. For instance, suppose the data are about human subjects, and then sharing the data publicly will expose the subjects to privacy risks. People can correlate different data sets and then figure out who's who, including those with terminal diseases and so on. There gotta be ways to do this in a more secure and private fashion, yet still checking precisely whether this paper can be reproduced.
So, I mean, I think my question back to Ben regarding the PNAS, if they're enforcing this rule of data sharing, I was actually exactly going to ask what happens in a situation that, I don't know, Census is trying to publish a paper and they clearly cannot share some of their original data, right? Or in the case of the medical studies, like what is PNAS doing actually in that case? Do you know?
I think they probably just said that if you don't follow our policies, they basically probably don't take your paper anymore. So it's your choice. They were really hard on us because we saw paper very similar data from 4 years ago. People didn't share, right? But this time when we submitted, they basically asked us, we said we'll share some secondary data. That wasn't good enough, right? It was basically they were ready not to even take our direct submission if we didn't agree to policy.
Well, that creates another problem, which is it's preventing in part the scientific growth, right, and learning and modeling new data and learning new results, and so.
So this is like type 1, type 2 error, right? It's a trade-off. So I mean, I'm just saying that they're taking a very hard line.
So maybe one additional point to make is that potentially it could be that the journal or some third party is the one that runs the code on the data that then gets the results of that are what appears in the paper, and then you have this third party which is actually you hopefully can trust that they indeed ran the code that they were told to run on the data, and that could also help maybe not reproducibility but trust in the whole system.
Yeah, on that, I did talk to Nature a couple of years ago about, because I was pushing stability. So they were very open about if I run a stability check site, and they're happy to say that if they pass the certificate, they're happy to consider that, but they're not going to run it. So that's like the idea. If consortium of some sort will do some reproducibility check, and the journals probably can respect that and take that, but they don't want to run it.
Right. But some third party that is holding the data and also running it.
Or people can submit the data subject to some random checking.
Any other questions? I thought there were some hands up that I wasn't sure. Okay. So I'm just want to give everyone a chance to kind of then maybe come back to how we started. So some statisticians have defined statistics as the science of learning from data and of measuring, controlling, and communicating uncertainty. We talked in this semester here and in this workshop, we speak a lot about uncertainty. And so I just, any thoughts and comments, again, how the privacy fits with particularly this definition of statistics, and, data science, I think, fits within this definition. It just came from a statistics literature. So if you just want to wrap up or say something about that, so uncertainty and how we deal with it. Thomas?
Yes, statisticians are the masters of dealing with uncertainty, so surely they should have no trouble dealing with differential privacy.
That's what Ben Yu said earlier, but it seems that's not the case. So, but you feel that at least the formal concepts of privacy coming along, again, I'm trying to be more general than just differential privacy. It is about, uncertainty, and that should play along well with statistics, right? But, maybe there are other opinions.
I understand that, more uncertainty is not a good thing, but I do think it does fit into the overall picture of the science of data analysis. So you now have a new source of uncertainty, you have to deal with that, you need to understand it, you need to analyze it, and hopefully you're actually going to get less uncertainty because you now have access to more data. That's fun.
Good point.
I guess if we go to like Ben's proposal for like essentially basing a lot of the first part of statistics on just perturbation analysis and stability there, then what's interesting to me actually is that then you have the output of a differentially private algorithm that actually comes from a probabilistic model. There, the probabilistic model is correct because we've made it. We made it happen. So all the tools that we have for inference there could be applied maybe fruitfully. Just the old methodology could be applied fruitfully. The privacy part is just like our old models again. Because now we've replaced our original probabilistic modeling with something that isn't based on probability. That's very weird and speculative, so I'll end on that science fiction note.
So statistics is about harnessing probability distributions and how do you make inferences from sample data to the underlying parameter. And differential privacy is I think one of the only cases where the statistical theorems about particular probability distributions can be directly applied. without worrying about the assumptions is wrong because we generated this additional randomness. This is one of the theme of this workshop. I think it is really important and people should do this more to use statistical tools to actually capture and harness this additional randomness from differential privacy so that we can make more valid inference.
I feel like I should say that, like using computers to answer randomness. It may not be perfect.
What's the probability that AES is correct?
Right.
We're all running epsilon delta. It's just a question of what the delta is.
Yeah. John and Ben, and any last comments?
I would say that there's a trade-off. Sometimes for privacy, you have to have increased uncertainty. And I think it would be very interesting for the community, both statistics and privacy community, to understand a few canonical cases in context to see how this trade-off plays out, and then generalize from there so other areas can borrow pretty empirical experience to do this exact or like more practical trade-offs.
Okay, last question.
Thank you. Sorry. So the discussion about other sources of randomness kind of caught my attention because something that's been on my mind for a while is, and this really isn't relevant to the project that I actually work on, the decennial census, because sort of ostensibly there is at least no sampling error. But for every other product at census, essentially, there is substantial sampling error, as well as a number of other sources of error, measurement error, non-response error, et cetera, et cetera. Something that I found very interesting is sort of digging through Adam's old blog posts is that there's sort of a secrecy of the sample style amplification theorem there, that under some mild assumptions we can sort of abuse to take advantage of some of this extra noise to sort of amplify or reduce the privacy loss budget that we're actually expending in practice in some of these survey-based products. That seems really important to me because it's going to be very difficult with the sample sizes in those products if we don't take advantage of that extra sort of noise structure, I think, to get epsilons that are going to make anyone happy on either side of sort of the discussion about where epsilon should fall. But I guess I was wondering, I think it's clear to me, and hopefully others agree, that there needs to be more work of that kind because those results are very special and they only apply to very particular cases right now. But I was also kind of curious, with all of these other sources of randomness that are floating around, is there any other random structure we might possibly, plausibly take advantage of to sort of have similar amplification theorems? It could be in measurement error, it could be in imputation error, so imputation processes often introduce error. Sometimes they make things worse, as sort of I think some of our collaborators have discovered. Could be in non-response error or whatever, but if there's other opportunities for these kinds of amplification theorems, I think they could be a really valuable source of privacy and practicality. So I was wondering if you all had any thoughts on that.
Actually, a naive question is that how does random projection relate to privacy? That's another way people add a lot of randomness to data these days.
Yeah, it's used. There's a paper called Johnson-Lindenstrauss transform. Itself preserves differential privacies, or here.
Oh, okay.
Yeah, someone. Or wrote that paper. So yeah, thanks for the question. So I think we need to distinguish between the kind of randomness that we can enforce and the kind of randomness that we assume. So for every assumption that we make, we can make use of that and then do a sketch calculation and figure out the corresponding implication of that in privacy. But that's not real, at least in the adversarial world. But in terms of subsampling, in terms of survey sampling, those are really things that we can enforce, and we can talk about how the implication of that in the accuracy utility, privacy utility trade-off that's being deployed in the census.
So you would kind of rather not use measurement error, say, but be very
I think from the worst case view of the world, I'd rather not use it.
Could be no measurement error. Maybe.
Well, we don't control the measurement error in the same way. So I think that's the hard part. I think it's what they're saying about modeling. Like, if I go to my electrical engineering friends and I say like, oh, working on differential privacy, and they're like, well, great, all the noise is Gaussian anyway. There's always noise in your system, so everything is already private. Which is not, and then you're like, yeah, this is bogus. But why is it bogus? Because we just assumed that the noise was Gaussian because.
But so many sampling error and like imputation error, for example.
Right. If you know the size of the error, then it might be actually doing privacy for you.
I think it would have a hard time getting it past the reviewers.
So there's.
Okay. If Thomas, you want
So I think imputation is something that's very interesting because potentially it's actually bad for privacy. Like if my data gets replicated to a bunch of times to other people, like maybe that's harmful to my privacy. So there's also a danger that some of these processes, which we might think are good for privacy, are actually sort of giving some people better privacy, but also hurting others.
Any last comments? Thank you very much for your insights and your comments, and thank you everyone else for your participation and